Dear friends, today we are seeing about some important equations regarding the sum of the natural numbers, the squares and their cubes, and also some problems. So, first we will see for the formulas. The formula for the sum of n natural numbers, the first formula 1 plus 2 plus etc. plus n, it is equal to sigma k is equal to 1 to n k. We are giving the values for k. Then when you are adding all those, you will get n into n plus 1 by 2. This is the formula which was discovered by Gauss, a great mathematician, at the age of 5. Actually, incident occurred, there was no class and the students were talking. Then the class teacher came and gave such a problem to the students and went. Then Gauss thought that it is a problem which was already solved, and he found out, he counted all the numbers from 1 to 100. Actually, the teacher gave like that, and he did a method and he found the formula n into n plus 1 by 2. Then it was generalized and the formula became his. Next is the sum of squares of n natural numbers, that is 1 square plus 2 square plus etc. plus n square, that is sigma k equals 1 to n k square is equal to n into n plus 1 into 2n plus 1 by 6. The next formula which you have to remember is the sum of cubes of n natural numbers, that is 1 cube plus 2 cube plus etc. plus n cube is equal to sigma k is equal to 1 to n k cube, that is equal to n into n plus 1 by 2 the whole square. The easy way to remember these formulas is the first and third formulas has some correlation. First is sum of n natural numbers n into n plus 1 by 2, and the third one is sum of cubes of n natural numbers, that is n into n plus 1 by 2 the whole square. And for the sum of squares you have a different formula, you have to learn it, n into n plus 1 into 2n plus 1 by 6. Now we are going for the problems. So, listen to the first problem, express the following sum in sigma notation. First problem is 1 plus 3 by 4 plus 5 by 9 plus 7 by 16 plus 9 by 25. So, what is the solution of such a problem? Here first what you are going to do is you are trying to write this problem as a general case. So, you know that 1 could be written as 1 by 1 or 1 plus 1 divided by 1 square, like that. Then the next is you have to see the numerators 3, 5, 7, 9. So, you are trying to express, they are all odd numbers, you express it as 2 plus 1, then 3 plus 2, then 4 plus 3, then 5 plus 4, and in the denominator 4, 9, 16, 25. So, 2 square, 3 square, 4 square, 5 square. So, as a general case you can write these equations as sigma k is equal to 1 to 5 k plus 1 in brackets whole divided by k square, that is sigma k is equal to 1 to 5 2 k minus 1 divided by k square. Now, what you have to understand is the remark, that is the problem is not a unique way to mention things. You can start the same problem with k is equal to 0. Then you will have the answer as k is equal to, there are 5 terms. So, if you are starting from k equals 0, you have to write it from k is equal to 0 to 4 2k plus 1 the whole divided by k plus 1 whole square. The same thing you can start with k is equal to 2, then again you will have the same formula you can write, you can start with k equals 2. So, where should it end? It should end at 6 because there are 5 terms, and you can write and make the shift as 2k minus 3 divided by k minus 1 the whole square. Next one is starting with k is equal to minus 3, the same formula, it is equal to sigma k is equal to minus 3 means minus 3 minus 2 minus 1 0 1. So, the last term will be from k is equal to 1. So, you start from k equals minus 3 the lower limit of summation and 1 is the upper limit, you can write it as 2k plus 7 whole divided by k plus 4 the whole square. So, when we are dealing with such problems, it is easy to find, there are different methods. Now, in the next problem, problem number 2, we are evaluating some sums, that is first one sigma j is equal to 3 to 102 j minus 2. So, we are making use of different properties of summation to do that problem. We can evaluate the finite sum as here from 3 to 102 you have to write. So, you are splitting it into 2. First term sigma j equals 3 to 102 j minus sigma j equals 3 to 102 2 by making use of property 1. Previous class we learned about 7 properties, making use of those properties here. From j equals 3 to 102, you can write that as j equals 1 to 102 minus j equals 1 to 2. So, the first term you have split up and wrote it as 2 terms. So, you can write sigma j equals 1 to 102 j minus sigma j equals 1 to 2 j minus the last term sigma j equals 3 to 102 can be written by the property 5 and 6, 2 into 102 minus 3 plus 1. The next step you can write it as 1 by 2 into 102 into 103 minus 1 by 2 into 2 into 3. So, minus 200 because the sum of n terms, the formula is n into n plus 1 by 2. So, the final answer becomes 5253 minus 3 minus 200, you get 50, 50. Then coming to the next problem, sigma k equals 1 to 7 k into 2k plus 1. K equals 1 to 7 to k square plus k, splitting it into 2, 2 into sigma k equals 1 to 7 k square plus sigma k equals 1 to 7 k by property 1 and 2. Now, you are making use of the formula for sum of squares, that is n into n plus 1 into 2 n plus 1 by 6, you get 2 into 7 plus 1, 14 plus 1 by 6 plus 7 into 7 plus 1 by 2, the final answer becomes 308. The formulas are given in bracket for your references. Now, considering the next problem, how can you do this summation? Sigma k equals 1 to 5 k square by 225 plus k is sigma k equals 1 to 5 k whole cube, that is equal to 1 by 225, then sigma k equals 1 to 5 k cube plus sigma k equals 1 to 5 k whole cube. So, I will get 1 by 225, sigma k cube will become n into n plus 1 by 2 again the square, 5 into 5 plus 1 by 2 the square plus next term will become n into n plus 1 by 2, actually it will become 5 into 5 plus 1 by 2, but already there is a cube, you have to cube it and write. The formulas are given in the bracket. When you do the final sum, you will get 1 by 225 into 15 square plus 15 cube. 15 square is 225 cancels, 15 cube is 3375 plus 1 will become 3376. Now, coming to the problem 3, show that sigma I equals 1 to n I cube minus of I minus 1 the whole cube equals n cube. How will you solve this? Here something is given, you have to show that it is true. So, the easiest way to do is you are going to expand and write the sum of the given problem. Sigma I equals 1 to n I cube minus of I minus 1 the whole cube, that is equal to, you are giving first 1. So, you will get 1 cube minus 0 cube, then you will get the next term I equals 2, it will become 2 cube minus 1 cube, plus next term 3 cube minus 2 cube plus etc., etc. Last but one term n minus 1 the whole cube minus n minus 2 the whole cube, and the last term plus n cube minus n minus 1 the whole cube. So, in the above sum we cancel 1 cube with minus 1 cube, 2 cube with minus 2 cube, 3 cube with minus 3 cube, etc., etc., and n minus 1 whole cube with n minus 1 whole cube with a negative sign. So, you will get finally sigma I equals 1 to n a I minus a I minus 1, that is the first and the last term remains, all the others cancels, you will get a n minus a naught. That is the first term is becoming the last term and the next term is becoming the first term with a negative sign. Now, by a remark you are going to say that the kind of sum encountered in the above problem, it is called a telescoping or collapsing sum. What do you mean by a telescope? Telescope is something which is used to find or used to view distant objects. So, similarly here If you are given a sum like this, you are calling it as, you are doing the method and telling that the sum is a telescoping sum or a collapsing sum, means all the other things are collapsing and it is becoming small. So, when we are seeing about such a problem, when we use general result sigma I equals 1 to n a I minus a I minus 1 is equal to a n minus a naught to make use of in problems. So, when I asked to do sums using collapsing sums, I have to make use of this sum and carry on. So, this is enough for this class, I feel. So, students, thank you, we will see you later. Bye.